Welcome to The Explainer. Today we're exploring a monumental shift in exactly how software is created. Now, if you've been following software development for a while, you know that lately coding has become a little less about actually building things and a lot more about, well, fighting with configuration files. But right now, we're entering what can really only be described as an AI renaissance. We are looking at a fundamental return to the pure giddy magic of building things, and it's all being fueled by the staggering evolution of AI models like Claude. So let's unpack exactly how this technology is rewiring the daily life of builders, and more importantly, how you can prepare for it.
To really understand where we're at right now, it helps to remember where so many of us started. Think back to your very first experience with programming. For some of us, it was hacking together some HTML to make an eBay listing pop. For others, maybe it was programming a TI-83 calculator just to survive math homework. You didn't learn from a textbook, you learned by tinkering. And the magic was in that incredibly short feedback loop. You had an idea, you typed a few commands, and boom, the thing ran immediately. The core metaphor we need to think about here is distance. Over the years, the distance between having a great idea and actually getting it to run grew absolutely massive. But today, thanks to AI, that distance is collapsing right back down to zero.
Because let's be honest, over the last decade or so, programming turned into a bit of a frustrating slog. Before you could write a single line of actual logic, you had to fight your way through compilers, type checkers, build systems, package managers, and what feels like a dozen different config files. It was exhausting. But just look at the present reality we're shifting into. Today, you describe a problem in plain English, and the program simply shows up. It's that exact same magical calculator feeling from childhood, except now, instead of drawing a pixelated graph on a tiny screen, this calculator can write and deploy a complex distributed system.
To really grasp how incredibly fast this distance is collapsing, we have to look at the timeline of Claude's capabilities. Just 2 years ago, Opus 3 became the first model that was actually proficient at writing long-form code. At the time, that felt revolutionary. Then last year, Opus 4 was out there autonomously building complex Excel and PowerPoint files, but check out what happened last month. The Mythos preview model read the entire OpenBSD source tree and found a 27-year-old vulnerability. I really want you to let that sink in for a second. Almost 3 decades of human reviewers, fuzzers, and static analyzers completely missed this. The intervals between these massive, game-changing leaps are getting shorter and shorter.
And because of these massive leaps, API volume on the Claude platform is up nearly 17 times year over year, 17x. Model capabilities are moving on this incredibly steep exponential curve. But here's the catch, and really the challenge for us. Most business adoption is still moving on a linear path. There's this growing gap between what AI is actually capable of right this very second and what organizations are actively using it for. Closing that gap, that's exactly where the massive, untapped opportunities lie for developers today.
And when we do close that gap, the human impact is profound. Take the company Binti, for example. Their CEO, Felicia Coru, runs software that caseworkers use to place children in foster care. By implementing the Claude API into their systems to handle all the heavy paperwork and licensing, they didn't just save a few hours of admin work. They literally took 20 days off the process of licensing a foster family. 20 days! That isn't just some neat metric of business efficiency. That is a child connecting with a family nearly 3 weeks faster.
Section 1. How coding is changing.
So if the models are this powerful, how is the actual day-to-day work of coding changing to accommodate them? Well, we're moving completely away from traditional development and into an entirely new paradigm. Think about the old way. Synchronous coding. This means you're sitting at your keyboard, manually opening pull requests, staring at a screen, babysitting flaky CI tests, and manually tracking down every edge case yourself. Now think about the new reality, asynchronous coding. In this model, you deploy agents that work overnight while you sleep. Features like CI autofix automatically listen for test failures, read the error logs, and proactively fix the code so your pull requests are always green. Instead of staring at a screen for hours, you literally wake up, review the finished work over coffee, and hit merge. The absolutely crucial point here is this fundamental shift in our default behavior. The old default was completely synchronous. It was, I prompt Claude to code and I watch it work. The new default is asynchronous. I create routines that prompt Claude. Routines are essentially higher-order prompts. You configure them one time and they act like a trigger. So a routine can just sit quietly in the background watching a GitHub repository. And when a new bug report comes in via webhook, your routine automatically wakes up, prompts the AI agent with all the context it needs, and kicks off the coding work while you are entirely away from your computer.
Section 2. Simple strategies in AI for novice builders.
Now, you might be thinking this all sounds super complex, But these powerful new workflows aren't just for elite top-tier engineers. If you want to scale these agent workflows, cost is obviously a factor. Enter the advisor's strategy. It's a beautifully simple setup in the API. Step 1. Use a smaller, faster, cheaper model like Sonnet as your primary executor to just write the code. Step 2. If that smaller model hits a wall of ambiguity and gets confused, it just pauses. Step 3. It reaches out to a larger, much more intelligent model like Opus for advice. Once Opus advises on the solution, Sonnet takes that advice and goes right back to executing. Companies like Evalegal use this exact strategy to get frontier model quality, but at a 5 times lower cost.
To actually build these agents out in the real world, developers are using Claude Managed Agents. These basically provide the underlying infrastructure so you can ship up to 10 times faster. But obviously, to ship this fast, security and control are completely critical. Instead of executing code out on public servers, you can now use self-hosted sandboxes through providers like Vercel or Modal. This means the AI executes its work entirely on your own private servers. Furthermore, if your agent needs to, say, read your private data warehouse to make decisions, you can use MCP tunnels. This is a game changer because it allows the AI to securely access internal tools behind your company's firewall without ever exposing your private data to the public internet.
And because these tools are becoming so unbelievably robust, the old barrier to entry has completely evaporated. Look at Shopify, for instance. They have integrated Claude code across the entire company. And we're not just talking about the engineering org. Non-engineers, product managers, designers, data scientists, they aren't just shipping real code at scale now. They're actually using these AI agents as interactive tutors, learning the underlying logic as they build internal tools. We're seeing managers and VPs who literally haven't committed a line of code in a decade suddenly building and shipping software again. The power of creation and learning is right back in the hands of the novice.
Section 3. Preparing for future AI capabilities.
So, as incredible as all of this is today, the models are only going to get smarter. So here is your checklist to make sure you're prepared for the inevitable future. First off, you must build for the next model version, not just what works today. Anticipate the growth. Second, and this is absolutely critical, use generalized primitives over restrictive scaffolding. Scaffolding is basically all that extra rigid code you write to guide the AI, the strict loops, the hard-coded instructions. As models get smarter, heavy scaffolding actually holds them back. A highly intelligent model does so much better when you just give it a sandbox, access to a file system, and let it figure things out naturally. Third, keep making your internal evaluations harder so you can instantly detect when a model suddenly becomes capable of a previously impossible task. And finally, treat every single model upgrade as a massive business opportunity to unlock brand new product features.
You know, one of the best ways to measure this incoming wave of intelligence is by looking at the task horizon. This is essentially how long a model can work autonomously before it loses the thread and gets confused. Today, agents can reliably run for hours at a time. But the expectation for tomorrow's generation of models, those agents will run continuously. We're talking proactive, always-on agents. Instead of giving it step-by-step instructions like write a project update, you'll just hand it a high-level goal like keep this project on track this week. The agent will use its own judgment, coordinate with other agents, and execute that overarching goal continuously over time.
We are standing at a truly unique moment in the history of technology. The restrictive scaffolding is falling away. The intense friction and slog of the last decade of software development is actively being replaced by intelligent agents that write, test, and deploy while we sleep. The distance between having a brilliant idea and actually seeing it run in reality is rapidly collapsing to zero. So the only real question left for you is this: what will you build?